Bismillahirrahmanirrahim. Sallallahu ta'ala ala Muhammad sallallahu alayhi wa sallam. Student, today we will start our lecture about class 10th, Theorem chapter 11, Theorem 4. If two angles subtended by two chords of congruent circles at the corresponding centers are equal, then the chords are equal, right? If the two angles subtended by the two congruent circles, right? We can say these are the two circles and these two circles are congruent. This is point A, point B, and this will be the point C because we have to prove the two chords. And this is a point D. This is its center O. Similarly, this point is A prime, B prime, C prime, and this is a chord A prime, C prime, and D prime, where this is center O prime, right? So what we have given? We have given two circles and which having two chords, right? They subtended the two congruent angles, right? So what we have given, let's see, A, B, C, D, and A prime, B prime, C prime, D prime are the two congruent circles, are two congruent circles with center O and O prime respectively. Right? Where AC and A prime, C prime are two chords, of circles with center O and O prime respectively. Such that, because when we say that there are two chords, right, that then they may be making an angle. So this is our given thing, not our construction step. This angle and this angle, right? It is given. Angle AOC, major angle AOC, that is equal to major angle A prime, O prime, and C prime. A prime, O prime, and C. This is given, right? Major angle A, central angle AOC, and A prime, O prime, C prime. These two angles are congruent. This is given. And what we have to prove? We have to prove that these two chords, major AC, that is equal to major A prime and C prime. These two chords are congruent. We have to prove this. And to prove this thing, we have to show with the statement and reasons. Statements and reasons. So you can see wise AOC, a triangle. If we show the correspondence between the two triangles AOC with the correspondence of A prime, O prime, and C prime, right? Then you can see AO, the radius, it is a radial segment, the line segment from center to any point on the circle is called radial segments, and both will be equal, right? So we say that O A congruent to O prime A prime, right? O prime A prime. Radii of the same circle. Radii of congruent circles. Right? And the given thing is that Mayer angle AOC, that is equal to Mayer angle A prime, O prime and C prime. This is our given, right? And again OC, that is congruent to O prime C prime, radii of the same circle, of congruent circle. Sorry, it may be in the same circle also, congruent circles. Right? So you know that to prove the congruency of two triangles, we just need the three things: two angles one side, one angle two sides, or three sides are the three angles. So here we have given two angles and one side, so that's why the triangle AOC congruent to the triangle A prime O prime C prime. And what should be the reason? Look at this, one side, another side, and including angle, right? One side, two sides with including angle, it means that we have to use here side angle side postulate, right? In the last lecture I have told you that when we use the postulate, word postulate for the SAS, whenever we have two sides and one including angle, whenever we show the congruency of two sides and their including angle, then in the reason of congruency of triangle we must show SAS postulate. We must write in the reason SAS postulate, right? So whenever we prove that both triangles become congruent, then definitely their sides are congruent, their angles are congruent. So that is the reason we write that AC congruent to A prime C prime, and definitely this is hence proved. We write the hence. This is our required proof, right? Fine. Why is also you will understand it. This was the theorem 4 of chapter 11, right? I have written here the chapter 11. This is chapter 11, and you are listening to the lecture class 10. Okay, guys. See you. Allah.